Hi everyone, welcome to the next video. This is Solids of Revolution. This is the washer method. What you're going to find is that the washer method is really the disk method with a hole in it. So here's your objective. We're going to introduce the washer method to find the volume of solids. So remember that even with the disk method, we took the area of some area and then we revolved it around an axis of revolution. And when we did that with a disk method. We did that like the complete circle. So we had like this whole thing. So we had this representative radius of a disk, right? Was found by just going from the edge of the disk, the whole radius. Well, what we're doing with the washer method is that we end up with two radii. We have one with the capital R that's further away, and then we have one with the small letter r, which is closer. And so in order to find the actual radius, we're going to have to take the larger and subtract the smaller one off, and then what we have left is our actual radius. And that's what we're going to revolve around an axis. All right, so it's just the disk method that we learned before is a special case of the washer method, where this little r is just equal to 0. Okay, so the washer method came about as a more general method for situations where you can't use the disk. So let's review the disk just really quickly. We have this area from A to B. You can see this here, this area right here from A to B, and we want to revolve it around the x-axis, and we want to find the volume. And so we do that by dividing it into disks. And so each radius of the disk, right, is this length right here, and we called that capital R X. And so because it's a disk and not a washer, there's not a hole in the middle of it, we could have said that R, the big R, squared minus 0, right, because there was no washer, there's no hole in it, dx, and then if we integrated that from A to B, that would give us the volume, right? So this is disk, a generalized form of the disk. Okay, so but the washer method is a little bit different. The washer method, if I have the same thing where I have this curve right here, and then I have maybe another curve like this, and revolve it around, then what you can see is that I have this length, this radius, okay, so this is R of X, and then I have this one right here, this red one. And so this is a terrible picture, but what you could see is if I subtracted those two, this is little rx, if I subtracted those, then I would actually have then the area in here. So that's what this is about, is you're trying to find the area of the washer, right? And then take all the areas of the washer and add them up to the volume. So let's take a look at some examples. It'll be a little bit easier. Okay, we want to find the volume of the solid formed by revolving the region bounded by the graphs of y equals square root of x and y equals x squared about the x-axis. And so we can see that this is modeled for us. We have a picture, right? This is going to be the square root of x, and this is going to be x squared, which you can kind of see in there. I'm going to take this region, and I'm going to revolve it around the x-axis. It's actually going to look something like this. So even though this touches at the bottom, this part doesn't. This part is going to be the washer part of it. All right, so we're going to write the big radius is going to be the one that's furthest away from the x-axis, and that's going to be the equation, the square root of x, and then the smaller radius is going to be x squared. So we can see on here that we're going to set up the volume, and it will be equal to the integral from 0 to 1 of the big R, right? So I would have that squared minus squared dx. And so that would be this, square root of x squared minus x squared squared dx. And so that's going to give me, oh, and then don't forget, because we're finding the area of washers, round things, and so there'll be a pi out here. So I have pi times integral from 0 to 1 of x minus x to the 4th dx, which is going to give me x squared over 2 minus x to the 5th over 5 from 0 to 1. So 1/2 minus 1/5 is going to be 3/10. And so my final answer will be 3/10 pi. So this is number 12 on page 453. This is the first example, the first problem that you're asked to work in class. And so I'm going to be working all parts, A through D. And so these are the first two parts. I'm going to find the volume of a solid generated by revolving the region bounded by the graphs of the equations about the given lines. That's the very generic definition. And so this number 12 is y equals 2x squared, y equals 0, those are my two, and then x equals 2. So that's what I'm trying to find, and I want to revolve them around different places. So I have a graph. First thing I want to do is graph it. And so I want the graph of 2x squared. So I'm going to start at 0. And then if I put 1 in, then I've got 2. 2 in, I've got 8. So it goes way up here. I'm going to just do this. This is 8. So I'm going to have 2, 8. I'm going to write that up here, 2, 8, because x equals 2 is where I'm trying to do this. So boom, 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 boom. This is what my graph looks like right here. Okay, so this is x equals 2. And then this is y equals 2x squared. All right, so there's my little graph, right? So I want to revolve that around the y-axis. And when I revolve that around the y-axis, this direction, right, that is going to make a washer, right, the washer method. All right, so I need, since I'm going around the y, this is going to be a horizontal. So I need my equation set up as x equals. So the first thing I'm going to do is, instead of y equals 2x squared, I'm going to divide by 2. And then I'm going to take the square root. So it'll be plus or minus y over 2 square root equals x. Now, this is the top half of this, so I believe that I use the positive only. So I'll mark that out. So I'm going to use the positive. And then I'm going to set this up. So I know it's going to be pi. Always starts with pi. I want to go from, on the y-axis, from 0 to 8. I'm on the y-axis. And then the first radius is going to be this one right here, 2. So 2 squared. The second radius is going to be my other function, which is the square root of y over 2 squared, and then dy. Okay? So when I integrate that, I'm going to end up with, this is 4, so this is 4y minus 1/4 y squared from 0 to 8, and that's going to give me 16 pi, and that's volume, so that's going to be units cubed. All right? Now, if you're going to do this by the x-axis, the x-axis is more like a disk, right? So this is more like a disk. I'm going to change colors to blue. So this is more like a disk. So I've already got it saved in terms of y equals. So I'm going to have this pi, and this time I'm going from 0 to 2. And then my function is 2x squared minus 0, because it's a disk, not a washer, dx. All right? And so that's going to give me from 0 to 2 of 4x to the 4th dx, 4x to the 5th over 5 from 0 to 2 gives me 128 over 5 pi units cubed. All right, so I want you to look at those and see how they're different, because you have to change your orientation depending on which axis you're going to revolve it around. Okay, so these last two are changing the orientation once again. All right, so once again I have, this is my area in here, only on this first one on C I want to revolve that area around the line y equals 8. Right, so let's think about then what the length of the radius would be. Okay, so I have an outer radius, right, the long radius, and I start at the axis of revolution, would go all the way to here. Okay, so that's the outer radius, would be 8. Now the inner radius, the smaller radius, would be this right here. And this is what I'm trying to come up with, right? So if I take this one minus this one, I get here. So this right here would be 8 minus my function. So this will be equal to 8 minus 2x squared. Okay, so I'm revolving it around y equals. That's the same orientation as the x-axis. So when I set this up, I'm going to say pi times 0 to 2, right? So it'll be the numbers along the x-axis of the top, right, which would be the capital R, would be 8 squared minus then this small r, which would be 8 minus 2x squared dx. All right, so once again, the long minus the short, right, gives me that little, those radius that's inside the area that I need. Okay, so when I put this in my calculator, I think I work mine by hand because that's what I do. I don't know why. 896 pi over 15 units cubed. Okay, so I'm going to change color because we have this same graph. In fact, hold on just a second. Okay, I took a second and I drew it for us. All right, on the D, what they want to do is take this same region, only this time we're going to revolve it around the line x equals 2, right here, x equals 2. All right, so you can kind of see that if you do that, right, you're going to get something that is not a washer. It's going to look more like a disc. So that's how we're going to set it up, is more like that. Now, one thing you have to remember is when you're setting these up, when they're not on the x or y axis, you're still doing it in the order of, if it's towards the x-axis, top minus bottom, or right minus left, right minus left. Okay, so what we end up with then is we still have the pi. We're doing this with respect to the y-axis, so this is 0 to 8. On a previous problem, we solved for y. So we have x equals y over 2. Okay, so we know what our function is in terms of y instead of x. All right, so we have the outer radius squared minus the inner radius squared dy. Now, the inner radius is going to be 0 because it's a disk, not a washer. There's no hole in it, so there's nothing to do there. And then what we want to do here is right minus left. So to the right of the right is going to be 2 minus the left, which is y, the square root of y over 2. All right, and so then when you go to figure that, you could use your calculator or whatever. I ended up with 16 over 3 pi units cubed. Now, do you see that setting these up is everything? Because if you can't set it up properly, you're not going to get the right thing. And there's like about 1,000 different ways you can set it up incorrectly. So this is going to require a lot of practice, a lot of practice. All right, one final example. This is number 19 from your assignment. So once again, if you'll do these in your notes, then when you get to number 19, you don't have to do them on your assignment. Right? So for instance, we're going to be finding the volume of the solid generated by revolving the region given by these equations. All right, so let's graph them. So we have y equals x. So we have something that looks like that. And then we have the line y equals 4. 1, 2, 3, 4. So this. All right, and then we have the line y equals 0, which is the x-axis. And then we have x equals 5. So that looks like this. So we have basically this region right here. That's our region. And we want to revolve that around the line x equals 5. That's this, x equals 5. So we're trying to go around this axis right here. All right, so do you see that this is a disk? Not a washer, no hole. We can also see that since we're going around here, everything needs to be in terms of x equals, not y equals. So fortunately, that's pretty easy because x equals y and y equals x. So we have that on 19. All right, so we know it's a washer. We know it starts with pi. We want to go on the y-axis, so 1, 2, 3, 4. So 0 to 4, right? We have the outer squared minus the inner squared dy, and that since it is a disk, that inner one is going to be 0. Right? And then we have right minus left, so 5 minus y squared. Stop. Okay, so once you have that, then you can just go ahead and either multiply it out to work it by hand, or you can put it in your calculator. I would do several of these by hand just to make sure that you have it down. So once again, you have pi and then 0, 4. So remember that this would be 25 minus 10y plus y squared dy. So 25y minus 10y squared over 2 plus y to the third over 3. And then when you put that in from 0 to 4, you end up with about 124 over 3 pi units cubed. All right, so keep in mind this is the right minus left. If you do top minus bottom, look to see if you have a disk. Look to see if you have a washer. All you have to do is move this axis over a little bit more and you have a washer. This would be a washer. Notice that we are taking a region. Either the region comes up to it or it's away from it for either a washer or disk. There are other methods that you can use that are kind of beyond the scope of AB, cylindrical shells and some other things that you can use there. So, all right, so several of these are problems, 2 of these are problems from your homework assignments. I hope you took good notes, and I will see you in class where we'll do some more practicing.